Good morning, good afternoon, everyone. I trust that everyone can hear me. My audio is working fine. And welcome to today's session on SMC version 2, and specifically today's session will be SMC-D version 2. So here's a quick look at our topics, and in the first part of this session, I'll take us through a quick review for what SMC is and why we need a version 2. And hopefully most of this is review information for most of you. And that pace of that material, I will try to cover it fairly quickly so we can get to the reason we're talking today is about introducing version 2. But it is necessary for you to understand version 2. You have to have at least a little bit of the fundamentals, an understanding of the framework around SMC, what we now refer to as version 1. So we'll go through that review, and then we'll talk about version 2 and what it's about, and how IBM's delivering this solution, and what it takes for you to enable it, some things to think about, how do you verify the enablement. We'll also talk about the possibility of configuring it using your TCP profile or, of course, NCA. So that's kind of what we're looking at. We, again, as Sam mentioned, we'll pause a couple of times to take questions. So I think in most cases you'll find most of your answers will be in here, but we have some good reference material to cover some other topics as well. So if we take a quick look back on what SMC is, remember what this technology is about basically trying to provide optimized communications in an enterprise environment around the Z ecosystem. So here we're showing an illustration of SMC-R, and that's basically shared memory communications using RDMA. It allows two discrete platforms to communicate over Ethernet, and using what you see there in the green is the new technology, of course, is an RDMA-capable NIC. We refer to as an RNIC, an RDMA-enabled fabric. In this case, it's ROCE, Ethernet. And the green boxes in the OSs represent a new communication stack that's sockets-based. And of course, this has been described in an RFC, which we have a link to that there. So basically, the intent is to optimize the communication by taking the CPU processing of packetizing data out of the software stack and put it into the RDMA itself technology. And we refer to this as shared memory, so it's a producer-consumer model using socket semantics. So that's the SMC-R, which is basically the remote version or RDMA version. And as you know, we also have a SMC direct version of this technology. So in the same case, it's from the application standpoint, it's still the same model. It is sockets, but instead of using Ethernet, we use an internal fabric. And IBM Z created this technology, which allows us to use SMC communications inside the machine. But all the framework, the protocol rules, and everything that we refer to as SMC base is followed. And we just, instead of using Ethernet, we use a virtual PCI function and an internal fabric, very similar to hypersockets, except of course it's a different protocol. And of course, again, the data stays inside the machine, and you do not have hardware. So in terms of bandwidth and so forth, it's basically LPAR to LPAR or memory-to-memory communications. Again, similar to hypersockets, except very different in the sense that the socket applications, you can view them as communicating directly. So there's a remote version, there's an internal version, and you can also use both of them together, of course. And the protocol, when you connect over TCP/IP, the protocol determines whether you are on the same platform. If you are, it'll use the internal version. If you're not on the same platform, it will use the remote version. And so here you see a picture of both of them being used simultaneously, the remote platforms over ROCE, and the two operating system instances on the left are using the internal ISM version. And all the devices render themselves to the OSs as PCI devices. So the ROCE are real PCI devices, and ISM are virtual PCI devices. But the architecture appears to be the same. The communication protocol is the same, and at the lowest layer, we either use internal or external communications. And so that's how they both apply together. And then an important aspect of SMC is it is still managed by TCP/IP. So this reminder here is to show you that we actually have your TCP/IP protocol stack that provides the connection technology. And what happens is you will connect over TCP/IP, and we will negotiate the capability to switch to use RDMA or to use DMA inside the machine. And this is important, and we'll remind you is why we do it using this hybrid solution. But once we decide that we are capable to use SMC, then of course we'll switch out of band. So all the socket user data is sent out of band either using RDMA or DMA. So here what you'll see is your OSA and ROCE logically appear to be the same device. So they're associated together by some fabric ID, which we refer to as a physical network identifier. So here at the bottom you see the green stack is OSA and the yellow is ROCE, but the two adapters are logically bound together by this notion of having being on the same physical LAN. So again, connect with TCP/IP, preserving all of your qualities and services related to TCP, primarily anything related to load balancing or anything related to security, for example, TLS or authentication. We want to preserve all that technology and your administrative model around it, and then just simply exchange the data using the SMC protocol. And so that's a look at how SMC connects. And so just a reminder of what's the point of SMC. Again, the number one item or value point is providing optimized network performance and communications to our customers leveraging RDMA technology. And key to that, and that's the number one item. So the whole point is reduce CPU, increase throughput, etc. And so it's important to note that the applications don't see this. So they basically use TCP sockets. If they are, they're eligible to use this. And again, it leverages your existing Ethernet technology. So in our case, it's ROCE. It does not require a special switch. It's RDMA over converged Ethernet. It's typically provided in almost every switch itself. It also preserves your existing TCP connection security model. So again, whatever you're using for connection level security is preserved. And in terms of resiliency, SMC provides dynamic failover and load balancing between the ROCE adapters, so we will balance the connections and move them if we need to. And then in terms of it preserves your existing IP topology, your network administration model, operational model. And so what that really means in terms of ZOS is it really means that all of your Netstat, all your display, how you operate, display status, start, stop, everything related to SMC is integrated within your existing IP technology. Now, the IP topology part of it is also part of a limitation that we're going to talk about why we need version 2. But nevertheless, those are the value points of SMC you're familiar with. And then just a quick reminder on the internal version, if you, instead of ROCE, if you use ISM, here we show ISM being associated with an OSA, and now the two operating systems are on the same physical footprint. In this case is Z13. And again, we still connect over TCP/IP. We discover, oh, the two OS instances happen to be on the same footprint as part of the rendezvous, and we can dynamically switch out to use SMC-D. In this case, instead of using a ROCE adapter, we would use an ISM. And now the two instances can talk directly memory to memory over the memory bus without traversing an external fabric. So again, for SMC-D, you require an ISM virtual PCI device. It can be associated with your OSA adapter, just like ROCE was. And also, finally, on this chart, for ISM, you can also, your IP device, instead of being OSA, could also be a HyperSockets device. So same connection technology. If we connect over IP, you have an associated ISM device. We, again, can switch out to use ISM. So ISM can be associated with OSA or HyperSockets, and the association is always your PNetID. So you tell us what physical LAN your IP device is on, and then you configure your ISM device to have that same PNetID, and we will logically bind them together. So that's how we create this switch out of band to use SMC direct inside the machine. ISM, again, supports either HyperSockets or OSA for switching and using SMC-D. Now, I'm not going to spend a lot of time on performance, but this presentation today is going to be focused on version 2 of SMC, what is it, and specifically SMC-D. So I just want to talk a little bit about, just a quick reminder, I won't torture you with a lot of performance charts, but it's important that I show this to you because often this gets lost in all the how-tos and the how you connect, but you lose track of. I just want to remind, this is a standard set of benchmarks that we run for many use cases, but what you'll see is at the bottom of the chart, it refers to request response, which is a transactional workload. It goes from left to right, and then the RR10 means the number of connections. So connections continuously with no pausing or think time. There's no application logic. It just tests from the sockets API all the way through the network and back, round trip. And so this is standard benchmark, nothing changed for SMC. But as you go left to right, all we do is increase the payload size. How much is the application workload exchanging? So we go from, so you can start with a second, we go from 100 to 800 to 1K, 4K, 8K, 16K, so all the way up to 32K. And what you'll see, climb is the blue bar, of course, and that's throughput. And again, this is a reminder that this is SMC-D compared to hypersockets. So hypersockets is a memory-to-memory technology. It's very efficient, but it still uses packetizing, still uses TCP/IP stack. Where SMC direct basically communicates directly. And you'll see by the time we get to like 16K or 32K, you're getting 4 and 5x times the throughput, and you're starting to see things like 70 and 80% CPU savings for exchanging this amount of data. And so this is a pretty significant, and the response time in purple is also up around 80%. So as you see this kind of sweet spot for transactional workloads moving a little bit of data, the more data you move, the more it pays off. And finally, when you get to the right-hand side again, for streaming, now you're up around 8 and 9x times the performance, again, compared to hypersockets. And the CPU is almost 90%, response time almost 90%. So this is what we're looking at. And again, this doesn't really change what we see with hypersockets and a technology like ISM. This gets slightly better with every machine processors. So again, this is followed suit for both hypersockets and ISM. They've improved now to Z15. You can see our latest number on our performance charts. So again, this is the whole point of SMC, is its performance. This next chart, if you don't like the bar graphs, this just puts it in English, and it basically breaks it into 3 categories. It basically transactional small data, transactional medium-sized data, and then finally it summarizes the savings for streaming workloads. So again, the SMC-D is about performance, and performance of order of magnitude that is fairly significant for you. This is also a summary of looking at, okay, well, what about the SMC-R, SMC-D? So again, this is just a bottom line of SMC-R compared to OSA. So this is Ethernet to Ethernet, changing protocols using RDMA. Again, we see latency savings up to 80%, and we see CPU-related savings of 60% for RDMA versus OSA. And then again, on the right-hand column, comparing SMC-D versus hypersockets, we see latency savings and throughput up to 90%, and then the CPU savings, which as I've had discussions with you and customers, most of them go right to this bottom row, which is what's the CPU savings, and it is significant, or can be. Now, so what's the difference in SMC-D versus SMC-R in terms of value to you, to our customers? And so basically the check mark is it basically, that first check mark says it provides everything SMC-R did, that whole list, but now, and basically that's summarized as a sub-bullet, but then it goes on to say, oh no, by the way, it does this without requiring any actual hardware. So there are no adapters, cards, slots, switches, PCI bus, external packet, external management, etc. So no hardware, it's memory to memory. And then the resiliency is superior. I'm the architect, I can get to say this because I believe it's superior because there's no failover, there's no adapter to fail, there's no cable to break, there's no light optics to fail, etc. So because it's memory to memory, the resiliency is a better model. And scalability, virtualization, etc., much higher, on and on. So SMC-D is a technology that I think provides significant value to our customers, and so we are again reminding you of this as we go into what's SMC version 2 about. Of course, SMC is also available or becoming available on other platforms. Here's a reference to that information. So you'll see that SMC is available in various distros in Linux, and SMC-R is also available on AIX and System P, and there are the links to see exactly the details on each of those. Now, with all that information and background on SMC, what I'll refer to and what we'll start referring to as SMC version 1, which is the original version of it, we know that it was a layer 2 technology, and it was limited because of that. The SMC that was exchanged in terms of frames on the LAN, they did not have IP headers in them, and so basically it was not routable. And so when IBM created shared memory communications, the original version of ROCE was available, the standards, and the original version was not routable, and it has since changed. But nevertheless, what that's done, of course, is made SMC limited to IP subnets, so we could not cross. And so while TCP/IP can, anything with an IP header for that matter, can cross an IP router, ROCE could not. And so the SMC framework around SMC-D and SMC remote were all basically follow the same framework, the same architecture, and the same rules. And this is for many practical reasons that we wanted them to be the same. If we separated them and had them follow different rules, it would have been very difficult to manage. So today you can think of SMC as a holistic solution, and underneath it, it's either using a ROCE fabric or an ISM fabric. And nevertheless, because the rules are the same, you could not use either form of SMC out of a subnet. Everything was based on keeping the communications within a flat layer 2 network. So what that's done to SMC is basically limited its use case. Some customers could manage that, other customers could not, and it's limited its exploitation, how many workloads could benefit. Customers would have to evaluate, well, which workloads can actually do this, and could I make minor changes? But nevertheless, that has been a limitation on SMC version 1, the fact that it could not span a subnet. So we have seen this problem reveal itself in many ways, and I can show you several different illustrations. We see extreme cases where customers, for example, might have each of their ZOS instances on a separate subnet. And there are reasons for this. Those reasons may have diminished over the years, but there used to be some recoverability, isolation, valid reasons to do this. But nevertheless, for customers that have this type of IP topology, they could not use SMC at all. And if those customers had those same ZOS images as LPARs on a single footprint, then they also could not use SMC-D. So basically, although their IP connections can traverse the routers, of course, SMC technology could not. And so some customers would evaluate SMC using the SMC applicability tool, and they would discover that, well, I only have a few workloads that are actually eligible, or in some cases very few, or zero, and basically we're not eligible to use that. So that's been an issue. And we also see cases where customers have groups of systems. In this example, I show a single CPC, and I show ZOS images on the left and maybe some Linux images on the right, and perhaps they're provisioned on unique IP subnets. And again, while they could use SMC among the ZOS images and maybe SMC among the Linux images, that getting across the two types of images was difficult without them making some changes in their IP topology, which we did not want them to do. So once again, we see this permeate through different customer environments in terms of their configuration, how they have their IP topology structured. And again, it was a limitation, it was an issue. And that's what's gotten us to this point of how to lift that single subnet limitation, and that's called SMC version 2, which we'll introduce today. And it's going to provide that solution for us. So when we originally started with SMC-R and over ROCE, it was based on the ROCE standards. And when ROCE was originally shipped, it was a layer 2 technology, and here's a snapshot of the frame. And for us, the IB payload was an Ethernet packet. In our case, it was TCP/IP, or in our case, it was SMC was the actual payload. But basically, it had some IB headers in front of it that were used for the ROCE standards that allow us to route it inside the RNICs. But and then it had an Ethernet header on the frame itself. But nowhere in here was there, after you come out of the Ethernet header, you'll see the IB header did not have an IP header. So there were no IP packets here, and Of course, it wasn't routable. And ROCE V2 standards have been announced, have been available for a few years now in the field. Other protocols, other industries have been using ROCE V2. So at this point, I think it's fair to say that it's a somewhat mature technology, and it's in the industry, used by other protocols. SMC will now need to adapt to this notion of routable ROCE, which is referred to. And now you'll see that instead of the IB global routing header has been replaced by an IP. And in fact, the IP header will encapsulate our data in a UDP header. So it'll be IP over UDP, and a special UDP port's been defined. So this is a picture of ROCE V2, which as far as we're concerned will allow us to open up SMC, and the SMC-R part of this will be something we'll talk about in a moment. But this basically is the stimulus for us to create this concept of routable ROCE and SMC version 2. So that's what's going to happen there. And so now when I show you the same picture that we looked at earlier, and I have a couple of CPCs here separated by different subnets, and maybe an IP router with firewalls, you'll see that, again, we have the ability to use ROCE V2 to get across that router, and now we need to adapt the SMC protocol to support this concept. And so our packets will now be embedded, encapsulated in UDP packets instead of the layer 2 frames. Other than that, the technology will be essentially the same. So this is an introduction to the concepts around SMC version 2. Basically, it just means SMC over multiple subnets. And so what we wanted to do was remove the subnet limitation from the protocol. And basically, you can view it as the subnet really is irrelevant now. And this is for many environments. So with SMC version 2, we define the specifications for SMC. How do we take this ROCE V2 technology and adapt it for shared memory communications? And this is what version 2 will be about. Now, IBM will deliver version 2 in multiple steps. And the first step is what we're talking about today. And it was announced in the third quarter RFA. I have a link to that RFA there. And I also have some information on the next page about it. But basically, this is our starting point, is we will introduce SMC direct version 2. And of course, underneath it, we don't have ROCE V2, but we'll need something to change the ISM technology to move away from this layer 2 concept into something different to allow the packets to be non-layer 2 related. And that's going to be introduced with ZOS 2.4. The PTFs are shown along with the RFA coming up. And we also need an update in IBM's ISM technology, which was introduced in the IBM Z15. So that's the requirements, is basically ZOS 2.4 and IBM Z15 to get to SMC direct version 2. Now, as far as SMC-R, we've made a statement of direction of what's our intent, and that you can read that SOD in the same RFA, that where is this next step going to hit. And on this next chart, I actually have a copy of that statement of direction. And it basically says that IBM intends to provide this same support with RDMAs. So basically, we'd like to be able to provide version 2 of this with SMC-D first, followed at some point with SMC-R version 2. And so this is a little bit of that information in terms of how and why we're doing that in 2 steps. And basically, we'll have more information for this coming in the future. That's our intent for exploiting SMC-R for routable ROCE. And you'll see also in this SOD, we also talk about it's also our intent to provide this and work with our Linux distribution partners to update the Linux support to exploit SMC version 2 as well. You can see this in the RFA, and with any SOD, I want to just always remind you is that, well, it's an SOD, and so again, IBM statements regarding direction plans are always subject to change. Everything from business priorities to technology issues can occur, and because of that, you have to be careful with any SOD that, again, this may or may not ever happen. So keep that in mind. It's still a statement of direction for SMC-R. Now, getting started with SMC-D version 2, it requires a software change and a hardware change. And the software, again, will be shipped in our third quarter enhancements RFA, you saw that information. It will be 2.4 PTFs, and there's a TCP PTF of a VTM1, a PTF or APARS, I'm sorry, I'm listing here for NCA, and there's one for ZOS proper and iOS to provide some support for us as well. So there are the changes there for 2.4. And also for down-level systems, when you update a system and you want to turn on V2, your down-level systems will need a toleration APAR, and it's listed there as well. And if you have Linux systems that are using SMC and they're going to remain down level, then you also need their compatibility. We sometimes refer to it as toleration or compatibility, and they have a fix listed in that links as well. So before you enable V2, make sure any systems that's participating down level are updated. And then as far as your hardware, ISM version 2 capability is enabled or available with the IBM Z15, and you'll see the details there for the T01. There's the MCL number, and for the T02, it's in the base support. Now, in terms of I refer to hardware. It's, as we know, ISM's actually firmware, but again, in terms of enabling this hardware firmware feature, there's nothing to turn on in the configuration of the ISM VCHIT. So we'll talk about how you enable it, but you don't have to do anything special in the I/O configuration for the system to enable this feature. So there are the software changes, there are the System Z changes to enable it. Now, this next chart introduces the most important concept for version 2, and I think I'll try to slow down here a minute. I know the review was fairly fast, but I wanted to just look at what the base support provided and look now at how we change that. And I think contrasting the two views is important. But with SMC version 1, the scope of the solution was self-defined. It was defined by the scope of the layer 2 network. If you wanted to communicate with SMC, you had to be in the same layer 2 network. But once you open that up, you have a new scope. And the question is, well, what is the scope? How many subnets, or how do I control it? And so in order to do that, we try to minimize the configuration support and provide usability in the sense that you can have control. And the way you do this is with this notion of an enterprise ID. So again, the solution is intended for the enterprise. You'll see that when we get to SMC-R, we'll talk more about it, that it's not intended for wide area network solutions. And the question is, well, what is the reach? We'll talk more about that later. But the point is that you can define the scope now by just defining an enterprise ID, an EID, and then sharing that same EID, configuring it in the systems that you want to talk in the same logical group. And typically it could be your data center, or it could be smaller groups, etc. So again, the IP subnet is no longer part of the connection criteria. Since it can span multiple subnets, it's basically this notion of having common EID. So then when we get to what is the version 2 connection eligibility criteria? What does it look like? And so basically what you do is you form these logical groups by giving them all the E. You can think of it as a cluster. If you're in this SMC group, you get to talk. And how do I get in this group? We all have the same same EID. And then when we connect, the protocol that dynamically connects that we have today, it's been updated to exchange the EIDs. And if they have, in part of the exchange, you say, hey, we have a common group, we're in group 2, what have you, you can have multiple EIDs, then we can use SMC version 2. And the logical group could be small groups, business units, system roles, development tests, the entire data center, multiple close proximity data centers, etc. Now, today we're talking about SMC-D, and you know that we're limited to a footprint of the machine. But again, you have to think about, we're still on the version 2 topic. We'll talk about how this concept of the need applies to SMC-D here in a moment. But then there's a footnote. The fine print at the bottom basically says that when you define an EID, what you also do is you enable version 2. So when you turn that on, that's how you enable version 2 and define a need. And of course, you can define, well, I want this ZOS system to be in group 1 and group 2. Okay, fine, define them. We'll support up to 4 of those. And so a system can be in multiples. That will typically be rare, but it's possible. But the other connection criteria must also be met, and we'll talk about that coming up here in a chart or two. But you have to get started with version 2 by enabling a group, which is defined by this notion of an enterprise ID. So we'll talk more about that. Now the concepts around it are shown here. Again, it's just a conceptual view, but I might have two enterprises. They could be close data centers or machines on the same floor or different business units, production tests, Pepsi, Coke. There could be some separation, but here I show that there might be some overlap, and that's fine. So the systems that overlap might be in A and B, and that's okay. And so what we'll see here is that when the client, the TCP handshake occurs, it will now exchange its EID. In this example, it's B, and the service, in my example, I'm also in B, so I'll accept your proposal, and then the client will confirm, says, okay, we're both agreed that we're in this group called B, and so we're going to use version 2, and I really don't care about subnets. Perfect, so subnets are out, and we're going to use version 2. So that's what version 2 does, and the host dynamically exchanges this information. This is the same exchange that occurred for version 1. We just added the new information to indicate that we're version 2 eligible, and this is the group that we're in. Now, when you define these groups and you have to start thinking about them, we provide other guidance in the IP config guide, and we have a white paper we'll also talk about. But here's a little bit more about the concept. Now, these concepts here will be, you'll see pretty quickly, are more applicable to Ethernet and LAN technology and even farther. But the concepts, again, we try to have a common framework across SMC-D and SMC-R, and we know systems move around all the time. So when your DR sites and your movement, this will have to be, all of this will be taken into consideration. But again, in this example, I have two close proximity sites. I might call my two enterprises EIDs A or maybe even North Campus, and they're only 12 kilometers. So in this case, I'm just going to give all of these systems, even though they're not in the same physical buildings, I might give them one EID, and basically I'll use SMC-D for the same CPC, and I'll use SMC-R eventually for the remote connection. So in this case, they're all close proximity. Now you might manage systems that are farther away, and farther, we'll give you better definitions of what close and far means and some guidance. But for now, it's just concepts. And here, of course, we've exaggerated the distance. Maybe New York and Denver are your data centers, and perhaps they're 2,600 kilometers away. Of course, you wouldn't try to use SMC this far away. And even though it's routable, you start losing some of the advantages. And again, in this case, you might manage these systems and they might communicate with TCP/IP, but of course, we would say that these might be managed with different EIDs. And again, we know we'll talk more about movement of systems when we get to SMC-R version 2, but we do realize that you can move systems from one data center to the other, and this may happen regularly. And what we'll talk about is that your EIDs may be location-based. You might, for example, use something like to load your EIDs for your ZOS systems. Now, going back to focus from SMC version 2 and this concept of EIDs, let's turn our focus back to SMC-D again. Now, here's a high-level view of two groups of LPARs on the same system, and I'm just showing the ISM view. And the ISM view is actually a mirror image of your LAN, of your OSA or hypersockets networks. And again, we create these inherited attributes are created based on your PNetIDs. And the example on the left, I have a group of systems called Group A, and I have a group of systems on the right called Group B. And they might be using different physical LANs. A uses a PNet A, and the B systems use PNet B. And for some reason, they need to be separated on different LANs. They don't even share the same fabric. And that's possible. And of course, all your systems could be on the same fabric as well. But in this case, they're on two different layer 2 networks. And I'm showing subnets as VLANs here. But you can think of VLAN 1 as being a subnet, etc. VLAN 2 on the left being the same subnet. And then on the right, I'm showing VLAN 1 again. Now remember, VLAN 1 on the right, I chose that number to match VLAN 1 on the left, just to bring up the point that they're not the same VLAN 1 because they're on a different broadcast domain, different LAN, different Ethernet. But again, the numbering system could start over and it's VLAN 1, but it's a different IP subnet. Remember, subnets cannot be discontiguous. So in order to reach a subnet, you have to be on the same fabric. And again, I show VLAN 7. So here's a very simple topology, and you can see that I've given the 3 LPARs on the left the ability to access subnet 1, VLAN 1, and etc. You see how the topology is laid out on physical network, and it copies the IP topology. This is all inherited from your IP topology, your IP devices. And if I would show you the OSEs or the hypersockets on this diagram, it would get too busy to follow, but this is a mirror image of your OSA network or your hypersockets network. Now the question is okay, I really want to use your SMC-D stuff for example, LPAR 4 and LPAR 1. I really have workloads in those LPARs, but they're different subnets. I can't IP topologies. So I'm interested in your version 2 solution. Show me how that might work. And of course, the systems on the right, I'd also like to talk about maybe there isn't a workload that I would like them to reach across LANs and talk to. Now, not only is it a subnet thing, but it's a physical network separation. So let's look at that one as well. So first start with the easy case. How could LPAR 1 and LPAR 4 exploit this new technology to cross subnets? And so here, let's talk about what it takes. So enabling version 2 is one step, define an EID. And of course, as an architect, I always make it sound simple, but I like to believe that it is. So define an EID, and oh, by the way, now here comes the fine print. There are 2 types. There is user-defined EIDs. They'll have more value when we get to SMC-R discussions, but you can use them for SMC-D as well. But you can also just hit one button and say, you know what, I don't need user-defined, I just need a system EID. And that's self-generated or auto-generated. You don't define the value. It's defined based on the name of the system. And it's really intended for just this system, SMC-D only. But if you need group separation, so no, I don't like having one EID. I have this group A, group B system. I need them separated. Then you'll need user-defined EIDs. So it really depends on your level of isolation you need. But again, step 1, on your global config or an NCA, you can go in and define an EID. Pick one, either it's user-defined or it's a system EID. And Charles is going to take you through this. So right now, I'm just showing you the concepts. And again, the NCA support is in the appendix. I don't know that we'll have time to go through the panels, but it's really only 2 or 3 panels because it's just a couple of items. So remember, defining the EID enabled your stack for version 2. In this case, it's just SMC-D version 2. So now, what is the connection eligibility? What are the rules? So in order for 2 systems to connect, here's what they have to do. Both of those systems, the TCP server and the client, have to, of course, be updated, their software, to support version 2. If it's COS, you put on the 2.4 PTS we talked about. Of course, they have to execute on the same CPC. And that CPC must support ISM version 2, and it's only supported on the Z15 with the changes we talked about. Now, be careful about looking for something called ISM version 2 in HCD or ISM, because you won't find it. ISM version 2 is a term that's used for the protocol, but fundamentally it's ISM, but it just has this new capability. Step 3, you must, the 2 systems that we've updated, they have to have access to the same VCHID. So, of course, in order to communicate, you have to have the same internal fabric, just like hypersocket, just like ISM. You still have to be on the same fabric, but you can now be on different IP subnets, of course. And so, and then number 4, you must enable SMC version 2. And of course, now we all know how to do that. It's based on turning on either the system EID or define at least one user EID. Again, when you do that, your system becomes enabled for version 2. And then finally, your last step still is true. You cannot be, your TCP/IP connection cannot require IPsec encryption, because if it does, again, the IP packets must use IPsec, which is not supported for SMC. So again, SMC-D base supported IP connectivity over OSA or hypersockets. That rule has not changed. Now, normally, if you're going across multiple subnets, it will be an external Ethernet connection, but it could also be internal as well. But what we're saying now is your TCP/IP connection might go 3 or 4 hops and wind up back into your same CPC. And when it does, then at that case in time, you could in fact be eligible to communicate internally using SMC-D for version 2 for that connection. So again, The criteria is you both need to support version 2, same CPC on a Z15, must have access to the same VCHID, must have the same EID, and not require IPsec. Now back to our original picture. In this example, if I've updated LPAR 1 and 4 to support version 2, and I've updated my machine to support ISM version 2, then I've defined both of them to have the same EID, then the two systems will just communicate. Even though their IP communications are over different subnets, we now form a new internal connection that's no longer associated with those subnets or VLANs. It was created as part of the ISM version 2 support. That you can think of this as somewhat of a pseudo layer 3. We still don't use IP packets or an IP router is not inserted here. This is just basically allows us to recognize the architecture of removing this connection from your VLANs. And we form this new internal connection. You don't have to do anything to start this interface. So basically what this looks like in LPAR 1, it has a connection to VLAN 1 in the green. It also, because it's V2 enabled, it also has a connection to this X, which I'm calling here as this internal connection. So if I have any eligible connections, the systems will use the pseudo layer 3 or ISM V2 connections, which is no longer associated with your layer 2 connectivity. So this is technology that we created that's our version of an internal ROCE V2 connection. So again, all you did was enable the hosts with an EID and give them the same EID so they can be logically in the same group. And so now LPARs 1 and 4 can in fact communicate with SMC-D across IP subnets. So even though they're IP devices will take multiple hops to connect, they'll detect the fact that they're on the same machine, same VCHID-A, and same EID, and connect using SMC-D version 2. So that shows you how the version 2 technology works. I know you probably have some questions by now. We'll open it up in just a moment. And then finally, I'm going to talk about one more concept, and I'll try to wrap up here. But basically, for SMC-D version 2, there are really two key new concepts. There's this new type of connectivity, that's number 1, which I just spoke of. And it's, again, can be viewed as ISM version 2, a kind of a pseudo layer 3 connections. That gets enabled just because you have an OS that exploits version 2 and your machine's at the proper level. Now, number 2 is another key concept. So we've learned about EIDs, a new internal connection, and the third concept here is this number 2 I'm referring to on this page as this. Now we have this concept of associated ISM VCHIDs, which we've always had. It was associated by a PNetID. This is existing support. And on that previous chart, we didn't change anything with our, let me just go back there just a moment. Again, VCHID-A was called PNet-A and VCHID-B. So this allows me to talk to up-level and down-level machines. Nothing changed with my configuration. I still have association. Now, but what we recognize is that since the ISM connection is not associated with a physical network or a layer 2 LAN anymore, that we can also support unassociated VCHIDs. They don't have to have a PNetID. And that really does provide some usability enhancements, and it also allows the architecture to recognize, I don't really care what your IP device is. So this really provides some additional flexibility, but you'll have to start recognizing this terminology called associated and unassociated VCHIDs. Associated means you have a PNetID. An unassociated says, I'm not associated with any PNet. And so finally, how do I get LPAR 4 and LPAR 5 to communicate across VCHIDs? I can define a new ISM VCHID without a PNetID. Those two LPARs will activate it with a new VCHID, and now they can communicate using ISM V2 that's not associated with a physical network or an IP device or a VLAN. So basically, here I'm showing is A.Y and B.Y are connected to the same VCHID. All I did was define a VCHID and left the PNetID off and provisioned a FID to LPAR 4 and 5, and off they go. And I'll use that FID depending on who I'm communicating with. And eventually, so the ones that are using PNet-A and PNet-B, they have up-level and down-level systems still using SMC, so they really need their old VCHIDs. But the two that are across the new VCHID are basically declaring that I don't need IP association with my old VLANs. Now, this final chart shows, well, this is really nice. Why don't they all do that? And this is what we'd like to get to. Very simple. You don't need the old and the new. Ultimately, all the LPARs can connect to a VCHID that has no PNetID, and there's no associated IP device per se. So I can connect with my TCP IP connection over an OSA or hypersockets, detect that I'm V2 enabled, and use this single VCHID for all communications. Now, this requires that all the LPARs are up level. And once they are, I don't need the old configuration or new configuration. If you're coming to SMC-D version 2 from scratch, you could deploy it in this manner. Just update your OSs to version 2 and ultimately just provision one VCHID without any type of association with any IP device, just no PNetID. So now in a lot of our displays, you'll see associated and unassociated. Let's go ahead and see what it looks like when we go through some examples, and Charles will talk about enabling. Charles has done a lot of our development work and a lot of our testing, and so he's familiar with the look and feel, and he will take you through this.
All right, thank you, Jerry. So what I've done is put together the definitions that I had. You can code these same things in NCA, but I coded them in my profile. If you've already got SMC up, you have SMC global in your global config statement. And now we have this new SMC EID block that's in there. It starts with SMC EID and ends with end SMC EID. And you can specify 4 of these enterprise IDs in this block here. I specified 4. You can specify 1 through 4. And the rules for these guys, it take up to 32 characters. If you choose to have a shorter one, like my second, third, and fourth one, we'll just pad them to the right with blanks. And we allow uppercase A through Z. We allow your numerals 0 through 9. And we also allow 2 special characters, a dot and a dash, right? We can't start with a dot or a dash, and you cannot have 2 dots in a row, but that gives you a lot of flexibility for what your names are. Maybe you name it with your company name and then your lab name or location name and then your building name, and one's maybe dev and one's maybe test and one's maybe production. But these are just random names that I chose so that it demonstrates the different styles of names that you could use, right? I want to make sure you're aware of all the special characters, right? So I have 4 EIDs that I configured in this new SMC EID block. And also in global config, if you've done SMC-D, you know that there's an SMC-D parameter on global config that enables SMC-D. Now we have a new parameter on that statement called system EID. You can specify system EID or no system EID, or you can just let it default to no system EID. And if you specify system EID, we're going to, in COM server, we're going to generate a EID for you that will follow all the rules of user EIDs, right? But it'll be unique to that machine. So that's how you define it if you're defining it straight in the profile. We have backup charts for how you would do that with NCA. So this is a Netstat config display. After I used my profile, I brought it up on my test system, and I did Netstat config. And before, you would always see SMC global if you had it coded. And now you also see how many ever SMC EIDs that you specified. Those are the 4 that I specified, the first one being 32 characters long, and then the other ones that I've also defined, right? And then at the bottom under SMC-D, you see that we have SMC-D sys EID. That can have a value of either yes or no. If it's yes, then will also display the EID that we've generated internally. All right. If you've done any work with SMC, you may be familiar with this Netstat display. Stev links with the PNetID specified. You can say PNetID equal asterisk, and it'll sort all your interfaces by their PNetID definition. So now we have these new devices, the unassociated devices that Jerry was talking about, that are under the heading of PNetID none. In the display, it has asterisk, none, asterisk. And you see our unassociated guys, EZA, ISM U1 through U4. That U in the 7th position means it's one of our unassociated ones. So the name sticks out there, right? And we also say they're associated no, right? So that also indicates that's one of these ISM fabrics that have no PNetID associated with them. And one thing to note here is I have an OSA device up there, QDIO4104L, that has a PNetID, has no PNetID. In the past, traffic over that OSA would have never been eligible for SMC. But now with version 2 and with these unassociated ISM interfaces, they can be used by OSAs and hypersockets that have PNetIDs, but they can also be used by OSAs and hypersockets that have no PNetID defined for them. So you may start getting usage of ISM, SMC-Dv2 that you didn't have in the past. Right, and then at the bottom you see what you'd seen before. QDIO4105L is my OSA device. It has a net ID of 1, and it's associated. EZA ISM01 is the ISM interface that's paired up with it. So I've got 4 of my unassociated ISM VCHIDs, and I've got 1 that is associated. The guy that's associated can always be used by the OSA that has the same PNetID. The ones that are unassociated can be used by anybody. I don't have a chart for this concept, but we also added the ability to add PNetID equal none on that Netstat dev links display. And if you say PNetID equal none, you'll just show the first part of this display. You wouldn't see the PNetID, NetID1 stuff, right? And if perchance you had a PNetID named none, you would see these star none guys, and you would also show the PNetID of none. But we don't recommend PNetID of none, but we're using it internally. Now, this is a Netstat all display. It's showing my FTP connections. So I said Netstat all port equal 21, right? And so we've added some new information on there. If in the past you've done SMC, you would have seen this SMC information section at the bottom of the Netstat display. And it would have your SMC-D status as active, you'd have your link IDs and things like that. What's new is that we are now showing SMC-D version. That SMC-D version can be 1 or 2. And if it is 2, the last line we add to this display is SMC EID, and it says, which of the EIDs did you use to establish this SMC connection? In fact, it's b-use.this.1. is the one I used in my testing. So the Netstat all display is enhanced to tell you what SMC version you're using, and if it's version 2 which EID was used to establish the SMC connection. This is a new Netstat DevLinks display that was introduced back when SMC was originally introduced. If you've used SMC, you've seen it. If not, this might be totally new to you, but the DevLinks SMC display will show you all the interfaces that are using SMC. So in this first display, and this goes over a couple of slides, you see the EZA ISM01 interface, and since it's not U1, you know it's an associated interface. And he's interface type of ISM, and you see what PNetID is and what TRLE on the VTAM side of things he's using. You see he's ready, his GID, and you see all these stats about how many bytes have come in and how many bytes have gone out. All this information, that's information that was there for SMC before now. But as we go forward, we'll see some new information, some changes in this display. So as part of that display, if you have links for that interface, we've added the SMC version link is using. So that might be 1 or 2 as the other display. And also your SMC EID that was used to establish a connection. For version 2, as Jerry showed you in his chart, the VLAN ID is not applicable. So whereas for version 1, this might have said 1FOX5 or something like that, 501. For version 2, it always say NA. And so because this is version 2, we say NA. If it had been version 1, you might have a number there. And you also see the counts of how many bytes in and out and other stats for this SMC link. Now we finally get to the later part of this display. We see an unassociated ISM device. You know that because that 7th character is U, EZA ISMU1. It's also interface type of ISM. You can see the PNetID he's using, and that PNetID was associated with our stack here. The TRLE he's using. PNetID is always now going to be none for these unassociated ISM interfaces. And we collect the same stats that you'd seen on the previous interface. The associated interface is also here for the unassociated interface. So you can tell how many are using V1, how many are using V2, how many are using these unassociated interfaces, all from this one display. And this is the link information, the SMC-D link information that's related to that unassociated ISM interface. It will always be version 2 for the unassociated ISM device. It will never be version 1. Yeah, so you're always going to have an EID, and the VLAN ID will always be N/A for the unassociated guy. And again, we'll keep track of the number of bytes in and out, other stats on a per link basis. The other thing we see here is we tell you what the remote host type is. In this case, it's ZOS. My testing was between 2 ZOS systems. And you also see the remote host name listed here. In this case, it was TCP CS5. And that information is now flowing in the CLC for the first contact information. And so this will be helpful for you and for us in debugging issues that we might encounter when we're bringing up an SMC link. So the remote host name and remote host type are there. I have a VTAM background originally, so I had to have a VTAM display in here. Here's the DNet TRL display. Shows the TRLE that is in use for one of my unassociated FIDs. You'll see the SMC-D PFID on there. IST2418 is about the middle of your screen, maybe a little lower. And the VCHID. And what's going to be different here is for an associated ISM device, you would have said PNetID equal PNet1, PNetA, whatever. And for the unassociated guy, we're going to say ** NA ***. It's not applicable for an unassociated guy. You can see just below that dashed line, the upper layer protocol. This was for TCP/CS5, and it was for UOP interface EZA ISMv2. All right, so this is displaying OSA or hypersockets interfaces. Before, you would see if there was an associated ISM interface, what the name was. In this case, it was EZA ISM01. That's still there, but now what you have in addition to that is the unassociated ISM interface. That could be one, or it could be up to 4 of them, right? You see they all have the 7th character as U. If you only have one, only one's going to show. If you have none, this line won't be shown at all. All right, so remember the OSA I showed you that was on the PNetID display that had no PNetID? In his case, you would not see the associated ISM interface, but you would see the unassociated ISM interfaces. And so you see what ISM interfaces might be utilized by traffic that's initiated over this OSA. And that's the last display I believe I have for today. And that's all I had. Jerry, back to you.
Okay. Thank you, Charles, for taking us through that. So again, there's a couple of key points that Charles picked up on. You know, prior to version 2, ZOS COM server, we would not activate a device that didn't have an ISM device without PNetID. We had nothing to do with it. So today, when we bring an ISM device online, we logically bind it to an OSA or hypersockets device based on matching PNetIDs. Well, if it comes online and says, oh, wait a minute, there's no PNetID, we had nothing to do with it. So now we have this concept of, well, we do now bring them online. It's unassociated and can be used by many interfaces. So this whole concept of associated was the old school and unassociated is a new form. It applies to version 2. So that's an operational thing you'll get used to. Charles took you through some of the displays. Now he showed you the extreme case of having 4 ISM devices, but typically you'll have one unassociated, if any. And we would believe that most of you would get to unassociated as soon as your OSs all support the version 2 flavor. So now here's just some miscellaneous information. NMI, SMF, we're not going through that here today, but there's some minor changes. You can get to the programming manual to see what those were for updates, things for EIDs and so forth, and a little bit of new information that's related to ISM V2. So the background information and some of the guidance was kind of quick here. Like I don't have too many choices on EIDs. I don't really understand what should I do. What's best practice? Well, there's some things to think about there, but that we have a white paper out there that it will help you with a little bit more background. So between this chart deck and that white paper and our IBM Knowledge Center with our pub updates, with all that information, you should be able to get a pretty good start on how you might want to exploit this technology. And then finally, you might think about, well, SMC-AT, I'd like to, now how do I figure out, because it used to tell me which ones were indirect and direct. So the applicability tool allows you to find out how much your workloads can exploit this. And now this whole notion of dividing by direct or indirect is somewhat obsolete. If you have TCP connections that really meet the criteria that could benefit from optimized communication, you fundamentally you can get the SMC-AT. And so we made some minor changes in the report to tweak the wording to say that basically if you're version 2, you can now reach these peers. And so we can talk more about that. But for the most part, you still use AT, but just know that if it's multi-hop, once you're version 2, you can solve that. So So now we tried to cover the architecture. Charles tried to take you through a little bit of the usage, and I know you may have some questions. You may have to think about this a little longer before you can form those questions, but I put a few of them here. Some of you might be thinking, okay, so I have version 2, what does it do to my performance? And the answer is that, well, the actual exchange of data really does not change. The connection architecture changes a bit in the sense that, in the past when you were multi-subnet, it was easy, it was over, we couldn't connect. But now if both peers are V2 enabled, we can connect. So the connection architecture changes, but the data exchange does not change. So for the most part, you can think of performance changes as not changing. And this item is not about performance, about extending the workloads to use SMC in the sense that now you're multi-subnet. So basically it's about connectivity architecture, not the data exchange. So the performance charts that I showed you at the beginning basically have the same value. And then, well, what about network security now that I can connect over multi-subnet? So for SMC-D, let me back up. For SMC, we have a security white paper. We will update that paper around about the time that we ship the SMC-R V2 part of this solution, maybe a little sooner. But for the most part, for SMC-D, there's really not a lot to say. So I like to just frame this as no changes. And so essentially, whatever you do today to connect over TCP/IP, that is intended to be one of the strengths of SMC, is that your authentication and your encryption all still applies. So whatever you do there, if 2 TCP endpoints are allowed to connect with TCP, then you're allowed to connect with SMC, and that's just a question of whether you're in the same SMC V2 group, EID. And basically, together, they allows you to use SMC version 2. So, and then after that, after the connection is set up over the TCP/IP connection, of course, the data remains within the CPC itself, so it can't be seen outside the machine. So the security strengths are basically in the model or all remain the same. And then the question is, well, this is pretty fast. These guys talk kind of fast for me. I don't know if I got this, but did you just say all I had to do was configure an EID and go? And the answer is that, yes, so EID does 2 things. It defines the group you want to be in. This system is allowed to talk in this group, this SMC version 2 group, and at the same time, when I define one of those EIDs, it enables me version 2. And so now I answered the question as well. It depends because of this IP topology things. You can just go, of course, you get version 2, but what about this VCHA thing, this unassociated associated? This is a little confusing for me. How do I decide? So it really depends on where you're coming from. Do you have separated LANs? Do you just have your OSs inside the CAC that are all on the same physical network? What kind of separation do you need? All SMC groups? Or do you say, no, the system EID is all I really need. If you're in the same CPC, I'm okay with them using version 2. I don't have 2 groups of systems I need to separate. So it really depends on your level of isolation and control that you need. But for the most part, if you're an existing user, you may not have to change anything with VCHAs. If you're a new user, you might think about how you want to deploy them, either associate them with an IP device or leave them unassociated. So again, the white paper will help you, the IP config guide. If you have any questions, I would at least read the config guide and the white paper before I felt like I could not get an answer. So I think that's all the prepared questions I could come up with, things that we did not venture. I still have in the backup, I have the NCA charts of how to configure EIDs, and that's in there. Again, we're trying to enable multi-subnet for other workloads. I did not talk about cloud or containers. This is a target objective of the multi-subnet solution. We hope to have more discussion about that in the future. I did not put that in there. You may have some questions about, hey, does it work for containers? We will get to that question in the future. We'll talk about Linux in the future. It's again part of our SOD. So again, hopefully you're thinking in that same direction.